Okay, Assalamualaikum warahmatullahi wabarakatuh. Today I will present about our mini project, which is ventilation smart system. Okay, firstly, my name is Noriana binti Basmi, and my partner's name is Karinisa binti Abdul Razak, and my lecturer, Yusuf bin Farasi. So this is our content that we will present to you today. So we are using DHT22 sensor, which is temperature and humidity sensor. So the DHT22 is a basic low-cost digital temperature and humidity sensor. It uses a captive humidity sensor and the thermistor to measure the surrounding air and spit out a digital signal on the data pin. And then no analog input pins needed. Next is our the sensor specification. The T22 sensor specification are actually only need 3.3 to 6 volt direct current, and then it is digital signal by single bus output. So the sensor element is polymer capacitor. The range of humidity is 0 to 100%, and the temperature is 40 to 80 degrees Celsius. Next is the sensing time. It only needs 2 seconds, and interchangeability is fully. This is the look of the sensor. So for the problem statement, we all know that nowadays Malaysia currently experience hot weather, and individuals who are not acclimatized to hot weather are at a higher risk of experiencing heat exhaustion or heat stroke. So from the problem, we got an idea to make people easy to know the current temperature and make the window automatically open by added output using servo motor. And then from the sensor detection. And then for the motivation, uh, we want to make this mini project complete because we want to make people easy to know the current temperature in their house or room, and then to allow fresh air to enter the space and circulate, promoting better ventilation without making people have to open window by themselves, because we have a servo motor that will open the window automatically. And then because Malaysia is currently having hot weather and danger for people. Next is project objective. It enables monitoring of temperature and humidity fluctuation over time. And then this can be used to adjust ventilation system to optimize comfort levels. Lastly, it gives fresh air to the user. So I will pass to Karinisa for prior work and next.
Okay, thank you, Nordania. Alright, hi, Assalamualaikum. So my name is Kanisa. So now I will present about the prior work. So as you can see, we have 3 projects in our prior work. So our first project prior work is IoT, base temperature and humidity monitoring. So the project is using TeamSpeak as their cloud, and they are using 2 microcontroller, which is Arduino Uno and ESP8266. So second project is IoT weather station. The project is using DHT11 as their input sensor, and for the third project is interfacing DHT11 humidity and temperature sensor with the Arduino microcontroller. Right, so next. Okay, so now I will explain about the limitation prior work. So for the first project, which is IoT based temperature and humidity monitoring, so they are using ESP8266, which is designed for lower power Internet of Things application. They only produce data without any control. And lastly, the Arduino Uno is pricey than ESP32. And next. Okay, so next we have a limitation framework for second project, which is IoT weather station using the DHT11 sensor. So in the project, they are using ESP8266, which is designed for lower power Internet of Things application. Same goes like the first project, and they are only have two output, which is IoT weather and LCD display. Okay, so next. Okay, so last, the third project is interfacing DHT11 and temperature sensor with Arduino. Okay, so for the project microcontroller that they are using is big, which is Arduino Uno compared to ESP32. Okay, so and then the detected temperature data only will be displayed to the serial monitor without any control. Okay, so next. Okay, so now we move to next, which is about the scope and limitation. For the scope of our project is can produce 4 output, which is OLED display, LED, servo motor, and buzzer, and only detect temperature in some space. So next is the limitation. So the limitation of our project is ESP32 will operate using Wi-Fi, and some space are not covered by Wi-Fi. Hence, this project does not have direct supply. Okay, so next. So next, I will explain about our block diagram. So in this block diagram, we have input, process, and output. For the input, we use DHT22 as our sensor, and the process, we use ESP32 as our microcontroller and Visual Code Studio as our main platform, and MicroPython as our language. And lastly, for the output, we use OLED display, buzzer, LED, servo motor, and Favorite as our cloud. Okay, so next. Okay, so now I will explain about the flowchart. Okay, first is start, and then the -232 will measure, and then we have 3 conditions. So first condition, when the temperature is below 23 degrees Celsius, and the second temperature is between 23 until 28 degrees Celsius, and then third condition is when the temperature is more than 28 degrees Celsius. So now I will explain about the first condition. So when the temperature is below 23 degrees Celsius, the temperature will display on the serial monitor and OLED display. And the servo motor will close the window. And second condition, when the temperature is between 23 until 28 degrees Celsius, the temperature will display on the serial monitor and OLED display. And then the servo motor or the window will follow their last condition. And third condition, when the temperature is more than 28 degrees Celsius, the temperature also will display on serial monitor and OLED display, and the buzzer will beep twice, and the LED will blinking, and the servo motor will open the window. Alright, so after this 3 condition is done, the data from the sensor will be start to the cloud that we are using, which is our Favorite. So after all the flow is done, it will go back to early process. Okay, so next slide. Okay, now I will present about the schematic diagram. So now, as you can see in this schematic diagram, we have ESP32, DHT22 sensor, buzzer, LED, and resistor, OLED display, and last but not least, servo motor. Okay, next slide. Alright, so for the result and finding, okay, now is our result and finding. So this is graph based on Favorite IoT. So on this slide is show about the average humidity when in the morning, and then temperature in the morning. So based on the slide, we collect two different data, which is average temperature reading in the morning, and later I will show you for the in the evening. So, and then so the main purpose we collect this. Okay, this one is for the evening. So the purpose when we collect this data is because we want to know the average peak hour for the temperature rise. It is because our project is currently didn't have any direct supplies. So that's why we want to know when this project is suitable for the daily use. Okay, next slide. Okay, so now I will show you the video demonstration of our mini project. Okay, let's play.
Hi, Assalamualaikum. So today I would like to present you about our mini project. So our mini project is a ventilation smart system. So this project is using DHT22 as a temperature sensor. Then we have ESP32 as a microcontroller using MicroPython as a language. And using Visual Studio Code as our platform. And then we have buzzer, and then we have LED, and then we have OLED display, and also, and last but not least, we have a servo motor as our output. Okay. Alright. So in this project, our project, we basically we have three conditions. So first condition, if the temperature is below 23 degrees Celsius. Okay. And then second condition is when the temperature between 23 until 28 degrees Celsius. Okay. And then the last condition is if the temperature is more than 28 degrees Celsius. Okay. So now I will show you our first condition, which is when the temperature is below 23 degrees Celsius. So now, as you can see, the servo motor currently open because it's more than 23 degrees Celsius. Okay. So now, I will put the DHT temperature sensor into the freezer to get core temperature. Okay. Let's see the temperature reading to below 23 degrees Celsius. Alright, so now the servo motor is already closed because the temperature is 23 degrees Celsius. And then the OLED display will display the temperature reading and will display and then will display window has closed. Then for the serial monitor, it will display window closed and the temperature reading, and then will display cold. So now I will show you our second condition, which is when the temperature is between 23 and 28 degrees Celsius. Okay, now let's see the temperature reading. Okay, so now the servo motor is still closed because when the temperature is between 23 until 28 degrees Celsius, the servo motor will stay based on the last condition, which is servo motor or window will stay closed. And then the OLED display will display the temperature reading and will display enjoy your day. So for the serial monitor, it will display temperature reading and display comfort temperature, and then will display window stay. So now I will show you our last condition, which is when the temperature is more than 28 degrees Celsius. Okay, now let's see the temperature reading. Okay, so now the servo motor is open because the temperature is more than 28 degrees Celsius. And then the OLED display will display the temperature reading and will display too hot, and will display window has open. Then for the serial monitor, it will display window open, temperature reading and too hot. And then also the LED we're blinking and the buzzer will beep twice. Alright, so that's all from us for demonstration our mini project ventilation smart system. Thank you.
Okay, so thank you for watching the video. And yeah, that's all from me. Now I would like to pass to Nordania to continue the presentation.
Thank you, Karanisa. So for the conclusion, we can conclude that by completing this mini project, we are able to learn about DHT sensor and how it works. And then our project will continue can be used by people in the future by adding new features, which is to improve our project by getting a good power supply or else. And lastly, we can learn how to create a code for functioning sensor. This is our reference, which is the project that we compare from others and compared to our project. And that's all from us. Thank you.